The PowerPoint presentation in Advanced Automotive System Unit 2 and Session 1. In Unit 2, under the Session 1, we'll explain the topic Variable Geometry Intake Manifold. The table of content: Introduction, Name of Manifold Technology, Working Principle, Effects of Variable Intake Geometry, Application, Conclusion, Multiple choice questions, and as usual the references. The introduction. In internal combustion engine, a variable length intake manifold or variable intake manifold or variable intake system is an automobile internal combustion engine manifold technology. As the name VLIM, VIM and VIS can vary the length of the intake track. In order to optimize power and torque across the range of engine speed operation, as well as help provide better fuel efficiency. In variable geometry intake manifold, I've already told you that it is completely automobile internal combustion engine manifold technology. Variable geometry can create a beneficial air swirl patterns. Turbulence in the combustion chamber is defined as the ratio of mass density of air fuel mixture. Mass density of air fuel mixture. Next, the names of manifold technology are the various types of manifold technology that what we used in variable geometry intake manifold system. First one, VLIM. VLIM, it stands for Variable Length Intake Manifold. VIM, Variable Intake Manifold. VIS, Variable Intake System. In VLIM, VLIM stands for Variable Length Intake Manifold. In variable length intake manifold is a direct answer to the shortcoming of conventional tuned intake manifold. If a fixed length of intake manifold is optimized for a very narrow revolution band and its two sets of intake manifold, one with short pipe to serve high RPM, while another with long pipe to serve low RPM by using butterfly valves like the rotary valve, switching between long and short pipes. In the VIM, variable intake manifold system, variable intake manifold has been popular on naturally aspirated engines since middle of 1990s. The variable intake manifold is really used on turbocharged or supercharged engines. This is because forced induction offers a strong supercharging effects. So these are all the benefits of variable intake manifold system. In VIS, the variable all are an automobile internal combustion engine manifold technology can vary the length of the intake track. So one is shorter path and another one is a longer path. In order to optimize power and torque across the range of engine speed operation, and it will help to provide better fuel efficiency. So this is the ultimate advantages of that the manifold technology. So it gives that ultimate the better fuel efficiency. So working principle of variable geometry intake manifold system. So I will show you the two sketches. Number one, what it shows at lower RPM, and then that rotary valve is closed. So here the path of that the flow of fresh charge air, it is in that longer way. And another sketch, the air flow, the fresh charge, it flows through the shorter path and the rotary valve is opened. So what is the differences in between those two sketches? Number one, when the engine speed is low or lower RPM, say for example 900 RPM to 1500 RPM, it's almost we consider as a lower RPM, and by that time the engine runs at very slow, and that time it required that less fresh charge, less intake air. So that time the rotary valve is closed and the air is passed through the in longer path. In the another way, when the engine runs at higher RPM, say for example more than that the 1500 RPM, say for example 2000 RPM, 2500 RPM or 3000 RPM, 3500 RPM. So maybe on that time that engine required that more fresh charge, simultaneously that more fresh air, that intake air through the intake manifold system. So on that time automatically that rotary valve is opened, the path flow to the the fresh charge pass through the intake manifold in shorter way, so that it will very confident to move the air is entering into the engine cylinder, and it makes it that the proper combustion. In the design of these two separate intake ports, each controlled by the valve like the rotary valves, either closed or opened in lower RPM and higher RPM simultaneously, in two different manifold, and one with shorter path. I've already told that operates that in at full engine load. Another which is significantly longer path that operates at lower load. Effects of the variable intake geometry. The effects of variable intake geometry, there are two main effects of variable intake geometry. Under that, number one, swirl, and number two is pressurization. So here that slide show main effects of variable intake geometry in swirl. In variable geometry can create a beneficial air swirl pattern or turbulence in the combustion chamber. The swirling helps distribute the fuel and form of homogeneous air fuel mixture. In the combustion process, helps minimize engine knocking and helps facilitate complete combustion. At low RPM, the speed of airflow is increased by directing the air through a longer path with limited capacity, and this improving low engine speed torque. At higher RPM, the shorter and longer path opens when the load increases, so that the greater amount of air with least resistance can enter into the combustion chamber. Ultimately, this will helps to maximize to the top end power in DOHC designs. DOHC, it stands for double overhead camshaft designs. And of course, it will help to that the swirling action helps to that to improve the complete combustion. Once the swirling in action, that's inside the combustion chamber, so definitely the air and fuel mixture mix thoroughly in swirling action, and definitely it gives the benefits of complete combustion. So once the complete combustion, that what it's happened, that result it gives less fuel consumption, and definitely 100% we will get that 100% power. Complete combustion, 100% power. So that is the main advantages of this system, the swirling action, and with less fuel consumption. Next, effects of variable intake geometry. Pressurization. The pressurization effects similar to a low pressure turbocharger and supercharger. However, this effect occurs only over a narrow engine speed. The variable intake system can create two or more pressurized hotspots. Definitely it increasing the engine output. When the intake air speed is higher, then the dynamic pressure making a passage narrow or longer, the speed or the dynamic pressure is increased. So there is a two actions, swirl and the pressurization. Definitely it will help to that the variable intake geometry. Then finally that ultimate result, that what we get, that increasing the engine output. Increasing the engine output means less fuel consumed, and of course that complete combustion. So definitely it gives that 100% combustion. So we will go for that the next slide, the application. In the variable geometry intake manifold used, many automobile the manufacturers use similar technology with different names. That what I told earlier, VLIM, VIM or VIS, variable intake system, or variable intake manifold VIM, variable length intake manifold system VLIM. In the other hand, another common term for this technology is variable resonance induction system. So that it call it as VRIS. So next, conclusion. At lower RPM, the speed of airflow is increased by directing the air through a longer path, and this improving low engine speed torque. At higher RPM, the shorter path and the larger path opens when the load increases. The greater amount of air with least resistance can enter the chamber. Enter the chamber means it's a combustion chamber. This helps maximum top end power. By using of that the actions of the manifold system, the swirl and pressurization, So definitely 100% we will get that 100% combustion, I mean that complete combustion, less consumed of the fuel, and the maximum top end power. Maximum top end power. Next we will take up that the multiple choice questions. The valve is opened as the cam lobo and the cam rises. The option A bearing, option B piston, option C valve lifter, option D valve seat. The answer is option C valve lifter. Next, the size of engine intake valve is option A same as that of exhaust valve, smaller than that of exhaust valve, option C larger than that of exhaust valve, option D does not depend upon the size of exhaust valve. The answer is smaller than that of exhaust valve. Next question. The opening and closing of valve is respectively done by option A cam and a spring, option B a spring and a cam, option C gas pressure and cam, option D cylinder vacuum and spring. The answer is option A cam and a spring. Next question. On modern 4-stroke engine, the exhaust valve opens just option A before TDC, option B after TDC, option C before BDC, bottom dead center, option D after BDC. TDC stands for top dead center, BDC stands for bottom dead center, and answer is option C before bottom dead center, before BDC stands for bottom dead center. Next question. On modern 4-stroke engine, the inlet valve opens just option A before top dead center TDC, option B after top dead center TDC, option C before BDC, option D after BDC, bottom dead center. The answer is before top dead center TDC. Next question. A relief valve is fitted to the main oil gallery of an engine. The purpose of this valve is to? Option A, limit the maximum oil pressure. Option B, open when the oil is hot. Option C, maintain the supply if the gallery becomes blocked. The option D, stop the oil flow to the bearings. Answer is option A, limit a maximum oil pressure. So in this question, a pressure relief valve to perform the functions to maintain the predetermined value of the pressure oil, so that it will regulate the pressure to the main oil gallery. So that's why that answer is limit the maximum oil pressure. Next question. The purpose of valve clearance is to? Option A, allow the valve to expand. Option B, allow the sliding of valve the guide. Option C, ensure that the valve closed fully. Option D, ensure that the crankshaft is free to rotate. The answer is option C, ensure that the valve closed fully. Next question. The device used to measure the clearance between the valve and tappets. Option A, feeler gauge. Option B, snap gauge. Option C, slip gauge. Option D, micrometer. The answer is option A, feeler gauge. Next question. The exhaust valve temperature is about? Option A, 35 degrees Celsius. Option B, 100 degrees Celsius. Option C, 150 degrees Celsius. Option D, 500 degrees Celsius. Answer option D, 500 degrees Celsius. Next question. In VVT technology, each cylinder has option A, single valve. Option B, multi-valve. Option C, 2 valves. Option D, 3 valves. The answer is option A, multi-valve. So we'll go for that. The next slide is the references. So references to prepare the PowerPoint presentation, we are using that some textbooks and refers to that some website links, and the textbooks are a system approach to automotive technology. The electronics engine controls by using sensors and all, and advanced vehicle technology, and basic automobile technology, and I will show some internet links to you utilize to that refer the topic. Thank you for patience hearing. Thank you very much.